So we got 5 minus 3i divided by 1 plus 2i. We want to simplify this. Okay, so this is part of complex numbers when dividing. So I got 5 minus 3i divided by 1 plus 2i. Now that I have that, what I'm going to do is, in order to divide these two, I need to multiply the denominator by the complex conjugate. So we look at the denominator and we multiply it by the complex conjugate because that will bring it into a rational number without an I value.
Okay.
So we multiply it by 1. So we multiply it by the complex conjugate over itself, because then in fact we actually just multiply it by 1. The denominator will become 1 squared minus 2, because it's like a difference of squares, squared. And the top part, we can use normal multiplication, first, outer, inner, last, and we can work that out separately. So let's go. 5 times 1 gets me 5. And 5 times negative 2i gets me negative 10i. Negative 3i times 1 gets me negative 3i. Negative 3i times negative 2i gets me positive 6i squared. The moment you see I squared, just remember that's negative 1. I squared equals negative 1. So this can be replaced with negative 6 at the top there. And then 5 minus 6 becomes negative 1 in the next line. We can also see like terms here. We can see like terms, these two, negative 13i. Let's go to the next line now. In the next line, we got 5 minus 6, which is negative 1, minus 10 minus 3 is minus 13i. Then I end up with 1 minus 2i squared becomes 4i squared. And this negative 1 minus 13i over I squared is negative 1. So it becomes negative 1 times negative 4, which is, this is negative 1 again. So it becomes positive 4. And 1 plus 4 becomes 5.
Okay.
All right, then we then distribute it so we can get it into the form a plus bi. So we distribute the denominator to each part separately. So minus 1 over 5 minus 13 over 5i. So we can distinctly see which one is which. We can see a is equal to negative 1 over 5 and b is equal to negative 13 over 5. We've now simplified that over there. All right, so question 3b. We've got, so the question is asking us to find the value of x and the value of y. All right, so think about the idea of equating coefficients, right? So with that in mind, for question B, I've got x plus y minus 4 plus 2xi equals, now 5 minus y. I can write it into two parts, but before I do that, let's just recognize something. Can you see that this is the real part and this is the imaginary part there? All right, so here we only have an imaginary part. We don't actually have a real part, right? That means we have to create the real part from nothing. Okay, we have to create the real part from nothing. So in order to do that, we'll end up with 0 plus 5 minus y I, because there is no real part in this particular example, right? Okay, so from that, we've got our real and our imaginary, just like the other side. Let's bring these two and equate the coefficients, and let's bring those two and equate the coefficients, right? So if we do that, yeah, you got now it's going to be x plus y minus 4 equals 0, equation number 1, and 2x is equal to 5 minus y, because that's what's in front of I. And that's equation number 2. We can then move the y over and you get 5 minus 2x. So we'll end up with x plus 5 minus 2x minus 4 equals 0. That becomes 5. X minus 2x is negative x minus 4 equals 0. That becomes 1 minus x equals 0. And so therefore, x equals to 1. We then substitute. So what I've done is I've substituted that in there. So my y value is available straight from this equation, call it equation number 3, to find. And so y equals 3. X equals 1,
Okay.
y equals 3, and I've now solved that. Yeah.